In question 1, I want to use the graph of y equals f of x to answer these questions. And let's start with the domain of this given function. So let me just add a couple of arrows here to indicate the graph is continuing forever like this and like this. Anyway, the domain is all the x values for each point on this graph. So like, for example, this point corresponds to this x value, so it's in the domain. And this point corresponds to this x value, so it's in the domain. And even over here, this x value is in the domain because if you go down far enough, you are going to meet up with the graph since it's going this way forever. In fact, the domain of this function is all real numbers. So I'm going to put D for domain and indicate that it's everything from negative to positive infinity. So there's not an x value on the x-axis that is missed by this graph. Now what about the range? The range is the set of all y values that correspond to the points on this function. Now the range is not going to be all real numbers. Like for example, this number is not in the range because if you look to the right and to the left, you don't actually encounter the graph. In fact, this spot right here is the largest y value on this graph, and it looks like that corresponds to a y value. Here I'll mark it. Looks like it corresponds to a y value of 1. So anything above here will not be in the range, but 1 is. In fact, everything below 1 is as well, because any spot on the y-axis refers to at least one spot on the graph. So for this reason, I'll use capital R for the range. The range is everything from negative infinity up to and including 1. Next, we want to find the X-intercepts provided they exist. And this is any spot where the graph crosses over the x-axis. And I see there are two places where that happens. There is a spot here and a spot here. So if I want to know those values, it looks like this one has an x value of 1 and this has an x value of 3. So the x-intercepts are 1, 0, as well as 3, 0. So it's these 2 points where the graph is actually on the x-axis. And part D says, well, what about the y-intercept, provided that it exists? And that's where the graph crosses the y-axis, and that's the spot right here. So right here is the y-intercept. The x value there is 0, but the y value looks like it's -3. The last thing we're asked for is, well, what's the value of f of 4? So what does that equal? F of 4 means, what is the y value of this function when x equals 4? Well, here's x is equal to 4, and it looks like the corresponding y value is, well, actually also -3. So this notation here is asking the question of what's the y value on this function when the x value is 4, and it appears that it is -3. And that's it for this question. In question 2, we want to match the following functions to the correct graphs down here by using transformations. So these are all some type of an absolute value function. They're just located in a different spot. It might be good to start by maybe drawing what the graph of the absolute value of x looks like. So maybe I'll just put that over here. So if you're looking at the absolute value of x, I know its shape is this. It's a V-shaped graph. Could maybe label a couple of points on it. For example, if you put 1 or -1 into the function, you get 1 back for y. But this thing here is the absolute value of x, just a really basic sketch. Okay, that being said, if we look at A, B, C, and D, we're doing something to this graph that alters it. Starting with this one here, this is the absolute value of x minus 3. I'm going to make a note next to this to see how I'm changing the function, how this is different from this. Since this -3 is next to the x, I know we're changing the x values. And anytime that you change the x values, you will have an opposite effect on the graph. So this thing is actually going to go right 3 places. It's tempting to think it'll go left 3, but actually it goes right 3 places. All right, now if I look for the graph that corresponds to this graph moving right 3 places, looks like it's this one here. This is the spot 0, 0, but it's moved over 1, 2, 3 places. Okay, so graph 2, that is A. All right, now what about b? All right, here we have, okay, it's the absolute value of x plus 3. Now this 3 is outside of the function, so we're changing the y value. And the effect will be what we expect. And that means this is going to go up 3 places. So I'm looking for this graph, except it's up 3 places. It's not that one. It's certainly not this or this, but this looks good. This is up 1, 2, 3 spots. So 4, that's going to be the function b. Okay, so for c, all right, this is 2 times the absolute value of x. This 2 is outside of the function, so we're changing the y value. And this is going to double the y value. So I'll say double the y's. So what does that mean to double the y values of this graph? The one at 0, 0 has a y value of 0. And if you double 0, it stays right where it is. But these 2 points have a y value of 1, and if you double them, they go to 2. So it's like this point's going to move up, and this point's going to move up. Certainly it's not this graph, but this one makes sense. At 1 and -1, the y value is 2. So for 1, I'm going to choose C. I mean, by process of elimination, I know D has to be this graph, but does it make sense? This negative is changing the y values, and it says multiply the y values by -1. That will flip this graph upside down. For example, the y value of 1 here will become -1. This graph should be upside down like this. The note I would make for this is that we are reflecting the y values. And they go over the x-axis. So you could say like reflecting the y values over the x-axis. But I know that means 3 is going to be the function for D. And that's it for this problem. For question 3, we're given 2 functions, f of x and g of x. So here we have 5 over x and x plus 3. We want to find these 3 things or answer these 3 questions. And the first one is, what is f composed with g of x? So we're going to create a new function from these 2 previous ones. This has a definition, and it is as follows. What this means is you take the function f, and what you're going to do is, instead of x, you're going to substitute the function g of x. So you're going to put g of x in place of all the x's. And g of x is equal to x plus 3. So what does that mean for this equation? So f of g of x means you take the function f, which is 5 over x, but instead of x, you're going to replace it. You're going to substitute in the function g of x, which is x plus 3. So like you don't take x and multiply it to x plus 3. This thing actually gets substituted in place of this. That's actually the formula. We don't really even need the parentheses. You could just write this as 5 over just x plus 3. And that's it. Okay, next thing. We want to evaluate f of g of 10. And we have a formula for this thing. So what you can do is say, well, in place of this x, I'll put the number 10. So f of g of 10 is 5 over 10 plus 3, which is 5 over 13. And that's it. We have this function. We can evaluate it. And this is the exact value that we get as our answer. Now the last one is, well, you can put 10 into the function and we got a number back. That's fine. But what's the domain of this function? What are all of the numbers that we're allowed to put in place of x? There's exactly one number that you cannot put here because it'll cause a problem with the function. Anytime I see a fraction, make a note to myself that you can't divide by 0. This is not allowed. So the way you can address this is, you can ask yourself, is there a number that if I put it here, it'll put a 0 into the denominator? Basically, I'm solving this equation. When is x plus 3 equal to 0? Well, if you subtract 3 from both sides, that's when x is equal to -3. If you put this number into this function, the denominator is 0. That is an undefined value. But every other number is okay. any other number that you put in place of x won't put a 0 in the denominator. So what this means is, for the domain, it is simply, you could write, if you're being very brief, just, well, x can't be -3, but it can be everything else. Or you can say, in terms of intervals, I'm allowed to use every number from -infinity to -3, but not including it. But then you pick up and say, well, I can also use everything from -3 to positive infinity. And I'll use this union symbol to say, I have these two intervals, I want to include both in my answer. And that is it for this problem.